Hello, everyone, and welcome to Design It Day Automotive. This year, we're focusing on design for automotive applications. With a rich history in this market, YAGEO Group offers a wide breadth of solutions for engineers to adopt and meet a multitude of challenges. I'm Wilmer Compagnoni, and I lead the technical marketing team at KEMET. For this keynote presentation on meeting the challenges of the future of automotive design, we are kicking off the event with a panel discussion between Dr. Seung Hoon Baek, R&D Head of Wireless from Pulse Electronics, Dr. Phillip Lessner, Chief Technology Officer at KEMET, and Kevin Chien, R&D Head of Chip Resistors at YAGEO. We are really excited to also be joined by Adam Dawson from the analyst firm Exawatt, who will be moderating this discussion. This discussion will focus on trends that we are seeing in the automotive sector and addressing the role of components in these trends. If you have questions, we want to hear from you. Please go to kemet.com/did-contact, and we will follow up with your questions directly after the event is over. So let's start with a quick introduction of our panel.
Thanks, Wilmer. My name is Seung Hoon Baek. I'm an R&D Head of Wireless PBU at Pulse Electronics. I'm located in Vancouver, Washington, USA. My responsibility is to focus on leading antenna research and development for various wireless applications, such as smartphone, notebook computer, IoT devices, infrastructure, public safety, and also providing technical standards and product roadmaps. I joined Pulse in 2012 as a senior antenna engineer. I like that Pulse has a wide product offering from 27 MHz low band wave antenna to high gain panel antennas. I later led the wireless FA team as a global FA manager. It was a pleasant experience where I could learn customer demands and market trends, as well as help others. Before joining Pulse, I designed antennas in the automotive industry in Detroit for 4 years.
Hi, everyone. I'm Dr. Phil Lessner, Senior Vice President and Chief Technology Officer at KEMET. I'm based in South Carolina in the USA, and I'm responsible for working with the R&D groups in the different product areas on material process and product development. I'm in charge of managing KEMET's patent filings and our patent portfolio. I also work with universities and external companies to ensure that KEMET is using the latest technologies in its development. My background's in chemical engineering. I've been at KEMET for 24 years. Actually, I started at KEMET in tantalum capacitor development as the lead in developing our KOCap tantalum polymer capacitors. This evolved into a licensing deal with NEC Token and eventually KEMET to acquire Token from NEC in 2017. I became Director of Tantalum Technology in 2002, Vice President of Tantalum Technology in 2004, and assumed my current position as CTO at the end of 2006.
Hello, everybody. I'm Kevin Chien. I work in the resistor field around the, I work in the resistor field around 37 years since 1984. From the Philips, Taiwan, then moved integrate into the YAGEO in the year 2000. My career started from the needed resistor for 7 years and 30 years in chip resistor. Very lucky can participate in the product development with customer together and join the resistor manufacturing technology development as well as product revolution. Not only diversify chip resistor category to fulfill different MCU application technology and miniaturization, but also long-term stable and precision with higher component reliability level to meet AEC-Q200 criteria. We even step out to support our customer to upgrade the component application technology and board level reliability, ready to take the responsibility to challenge the system level reliability with our end customer together. The resistors are widely applied on the 5G IoT EV market. Each application field have their own specific criteria. YAGEO accumulated 40 years technology and experience continue to serve our customers.
All right. Thanks, everyone. All right, Adam, over to you to get this conversation going. But before the first question, can you perhaps please give a short introduction about yourself and Exawatt?
Thanks, Wilmer, and thank you for having me. I'm a senior research analyst at Exawatt. We specialize in technical and market analysis, cost modeling, and forecasting for the power electronics, electric vehicle, battery, and PV industries. More specifically, I lead Exawatt's work in power electronics, and in particular, silicon carbide semiconductors, and this is all driven by our work and analysis of the EV market. My own background is in mathematics, and I've now been at Exawatt for a little over 2 years. So the topics that you're going to be discussing over these few days and in this conversation are particularly interesting to us at Exawatt. We're doing a lot of work modeling power electronics requirements for electric vehicles, and we've developed detailed cost and demand models for the power electronics industry. And this is all underpinned by our analysis of the EV market, and we've been developing forecasts and monitoring the market for this as well. As I'm sure everyone's aware, the shift in the automotive industry to decarbonisation and electrification, and in particular battery electric vehicles or BEVs, is rapidly picking up speed. We believe that the competitiveness and benefits of EVs over internal combustion engine vehicles is only going to increase and is going to accelerate this switch in the coming years. We're also seeing increasing use of electronics in all vehicles for connectivity, autonomous driving, and more advanced system control. This presents even more opportunities for manufacturers as the electronic content of vehicles increases in all areas. So yeah, I'm really looking forward to hearing the panel's own views on how the automotive industry is set to change in the coming years. And the electronic and capacitor industries have a major role to play in driving these shifts, and the components of the YAGEO Group are a key part of the supply chain, so I'm really interested to hear more. If anyone does have any questions about the work we do at Exawatt or would like to discuss any of the topics that have come up today any further, then please feel free to get in touch with me. So getting into things and starting with the first question. As I mentioned, it's clear there's a big shift towards EVs, and this is not only from a shift in attitudes of consumers, but also government's initiatives and policy to encourage adoption. What are the panelists' thoughts about how the electrification of vehicles will progress? How do you expect the market mix of battery electric vehicles versus, for example, plug-in hybrids and fuel cell vehicles to evolve? Dr. Phil, do you want to take this one?
Sure. So let's talk about fuel cells first. So, you know, batteries certainly have a head start compared to fuel cells in terms of market adoption and building out the infrastructure for charging. You know, a decade ago, it wasn't really, you know, that clear about batteries versus fuel cells, and the Japanese car companies actually put a lot of R&D into fuel cell vehicles. But I think, you know, the success of Tesla recently has really caused most everyone to switch, you know, their focus to battery electric vehicles. But yet, you know, I still think there's a niche for fuel cells, and that could be, for example, in the electrification of long haul trucking. So that's sort of a different use case than the sort of the consumer type of you know, of automobile. For long haul trucks, in order to move, you know, those big loads over, you know, long distances, massive batteries would really be required. And the weight of these batteries is large, and it takes a long time to charge them. So using hydrogen as an alternative fuel could allow the trucks to go longer distance before having to refuel. And of course, you know, hydrogen is also a clean, you know, energy source, just like, you know, just like batteries. You know, other applications of fuel cells could be, you know, drones or electric planes. And there's been some, you know, recent buzz, you know, around drones and fuel cells recently for powering them. supercapacitors, that's another interesting, area, another alternative, or something that's complementary, more likely to, batteries or fuel cells. So I've been involved with supercaps since the mid 1980s, and of course they've been the next big thing for a while. But if fuel cells gain some market share, then supercapacitors would be needed to provide power, as acceleration in fuel cells isn't so good because there's some technical issue of getting all the reactants to the electrical converter. So it's hard to get high instantaneous power out of a fuel cell. So if for fuel cell vehicles, supercapacitors might make sense. Another area where they make sense, or as either alone or as a complement to batteries, would be in regenerative braking. And that's another application that's often mentioned in connection with supercapacitors. So yeah, fuel cells and supercapacitors, definitely on the radar screen. Then, there's really the question of, consumer uptake of electrified vehicles. How quickly can they improve, and what do you need to do to convince people to switch? I think for urban use, range and charging speed aren't as important, as most trips are less than 50 miles, and recharging can be done overnight or at work. The issue is really with people who take longer trips or go on vacation. Many households don't really want to have a second vehicle just for longer trips, where one internal combustion vehicle or hybrid vehicle will do. So until range and charging speed are fully addressed, I think that's going to somewhat limit the uptake of electric vehicles. But the good news is range is now improving. So there's some electric vehicles that are introduced with ranges over 300 miles, and then rapid DC charging is also being introduced. I think that will take a little longer to penetrate, because there you need to put infrastructure in, but once it's in, people will be able to get a significant amount of charge in 15 to 20 minutes, which is not quite where you are with gasoline internal combustion engines, but you're definitely getting close.
Thanks. That's really interesting. And you've mentioned quite a few topics, I think, that we're going to explore a little bit more detail further on in this conversation. And yeah, I'd just like to add, from our point of view here at Exawatt, we completely agree that battery electric vehicles, BEVs, are probably going to dominate in the near term, definitely compared to fuel cell vehicles. But there is definitely a future market for them, particularly in long range or high duty cycle applications. Also definitely aren't convinced by the value case for a plug-in hybrid. Probably think that once the cost of batteries comes down, that BEVs are going to be the cheapest option. Just as a kind of quick follow-up on that, how does the different types of vehicle and the different evolution of these markets affect the market for passive and other components that you specialize in?
Yeah, so no matter what the type of electrification, that's going to require more passive components than internal combustion vehicles, and that's really because you have more systems that rely on electronics and instead of mechanical effects. So as you go from mechanical to electronics, that really increases the number of all the electrical type of components that are in the vehicle.
Great. So I was wondering, now we could just move to talk a bit more about the kind of energy storage and the battery side of things in EVs. Dr. Seung, could you maybe provide some insights about what you're seeing in terms of the implications of electrification when it comes to passive requirements from a supply and demand point of view as well?
Yes, we have a very professional expert in the power division and also the network division in Pulse. But especially the wireless, I would like to mention about the wireless battery management systems. So we participated in the wireless battery management system project with Tier 1 automotive OEM. Unfortunately, our partner could not win a project from OEM, but we had a chance to learn antenna design and alignment skills for products that would go in the area under the cabin, because this area is not a wireless friendly environment. And then wireless battery management systems is forced to be enclosed in shielded battery system for safety. These are challenges to design a very reliable wireless connectivity. But however, the wireless battery management system could be an alternative solution to monitor battery system in the future.
Thank you. Certainly some more interesting applications coming out of this and opportunities. Now moving to Kevin, as a question for you. Would you be able to talk a bit more about what you're seeing in terms of the geographical variations in the changing automotive market, and also your opinions on different manufacturers? So who's geographically and in terms of manufacturers, who's leading or will lead the transformation?
For the many government that will set their own promotion policy with intensive scheme and combined with set a sunset rule for the ICE vehicle, that will turn around the national economic and provide fresh and clean air for their citizens to reduce the healthcare expenditure.
Yeah, so as well as the geographic variations, we'd also like to bring up the variation in OEMs and particularly new manufacturers coming into the market outside the traditional automakers. So what does the panel think about the involvement of new companies, both the EV startups like Tesla, we've got NIO in China, Lucid Motors and Rivian in Silicon Valley or in the US as well as now increasingly technology companies like Google and Apple, both in terms of building cars and from the autonomous vehicle perspective. So yeah, what do the panelists think about the introduction of these new companies? Phil, do you want to take that?
Yeah, so sure. These companies are really changing the landscape. So you're now not dealing with just the big European and American car manufacturers. There's a significant number of companies in China that are new to the automotive supply chain. So you need to deal with that. There's also non-traditional companies like Apple and Google working on vehicles or autonomous vehicles. So they also bring a different perspective to the whole enterprise there. And then there's really new players that are getting involved that traditionally were not automotive suppliers, like LG, for example, in Korea. So we're having to deal with many more, companies and many non-traditional players, which have quite a different view on requirements for components in some cases.
Kevin, do you have anything you want to add to that?
Yeah, for this technology, I think for the Asia people, there are more people joined this game to develop the new ECU to support all the applications. Yeah, we also cooperate with our customer to do their ECU in the related field. I think it's a way of getting better.
And Seung as well, do you have any comments?
Yeah, I think we need to talk about the benefit of 5G network for autonomous driving. According to T-Mobile, the attractive features of 5G network for autonomous driving are network slicing and low latencies. So one of sliced or divided sub-networks could be used only for autonomous driving. This dedicated sub-network enables to provide seamless connectivity to autonomous driving vehicles for ensuring safety relevant notifications without giving up any connectivities of infotainment services. Data processing time of a 5G network is faster because data centers are in close proximity to the transport route. Low latency enables to provide less distance mismatch between the actual vehicle location and the past vehicle location where vehicle transmitted a position signal. The trend of EV vehicle antennas is adapting fully integrated or hidden antenna solutions. So you can tell where the antenna locations is from the vehicle exterior. So you can, the typically 4 5G sub 6 gig antennas and 4 to 8 Wi-Fi antennas and 1 multi-band GNSS antennas are assembled in a compact package. Alternative non-metal material used to reduce the weight of vehicles and less use of metal-based materials in vehicle body structure like a panoramic sunroof could make the implementation of hidden antenna solutions on vehicle easier.
Does anybody else want to add on to that, or shall I move on to the next next topic? Anyway, moving on then. So to a new topic, to a topic that comes up a lot when discussing electric vehicles in terms of the infrastructure. So the whole industry needs to be building various charging infrastructure, particularly for BEVs, to meet the new demand, whether it's wireless charging, rapid charging, or home charging. How does the panel see this rollout keeping up with demand, or will infrastructure be a limiting factor to EV adoption? And also as well, how can component manufacturers such as yourselves influence and support this rollout of infrastructure?
Yeah, so the government initiatives, right, for the electric vehicles and the EV ecosystems. So government try to build more charging stations for the by 2030. So maybe more charging stations will increase buyers' consideration and buying electric vehicles. And also we participated in charging station, the project, wireless charging stations. So there is a 4x4 antennas included in the charging stations. So more charging stations and need a more antenna demand. And also big charging stations should connect it with the wireless. So there is a backup the cellular network. It should be installed in that charging station area.
Great, thank you. So if we move on and think some more about the eVision technologies, which is going to have, as you mentioned, a big impact on charging. But if we also move to new technologies when it comes to the power electronics and the powertrain, so this is an area that's related a lot to my work at XWatt. What do the panelists think about the potential role of wide bandgap power electronics, for example, silicon carbide and gallium nitride? Do you see the uptake of these technologies influencing the market, and how will new technologies and changing technologies such as these wide bandgap electronics influence system design in the market for passives?
Yeah, so it's definitely going to have an influence on design. The answer though depends in part on what the frequency of operation is. So wide bandgap semiconductors really have the potential to operate at much higher frequencies than silicon because of their low losses. But when you operate at higher frequencies, there's definitely some issues that need to be overcome. One issue is the higher electromagnetic interference, which requires additional costs to mitigate. Another issue is the losses in passive components, which is
Yeah, that's really interesting. And so we've already seen some volume for silicon carbide, for example, in EVs. So Tesla started using them in all their vehicles, but we yet to see a significant uptake across the rest of the market. So you've mentioned some of the challenges with the higher frequencies and what that means for magnetics. Just wondering if you could elaborate a bit more on, do you think the industry is ready to address those issues, and can it be done for a reasonable cost?
Yeah, well, we're definitely addressing it. So the issue with magnetics is the core losses at higher frequencies. They tend to be go pretty high. So that needs to be addressed, and there's a lot of research effort in materials that have lower core losses at higher frequencies. So I think in the next few years, it'll be addressed. I mean, it's definitely a challenging problem, but all the manufacturers are working on addressing that issue.
Great. So yeah, I'd just like to add that the silicon carbide in particular, but silicon carbide semiconductors is a significant focus of my own and our work in general at Exawatt. So I'm glad to have had the opportunity to ask these questions, and just fitting in a bit of a plug for some of our own work. Exawatt's about to launch a report on silicon carbide semiconductors and power electronics in EVs in the coming weeks. So if anybody's interested in those topics, please feel free to get in touch. Anyway, moving on to the next question. So we've talked a bit about the technology developments, and a few of the answers and questions have touched on the topic of cost, which is and for electric vehicles is currently a significant factor in terms of adoption, in terms of consumer adoption. So we're expecting EVs and ICEs to reach kind of purchase cost parity in the next few years, in the mid-2020s. Do the panelists agree with that? And how do how does the passive components industry help achieve this cost parity? Kevin, do you want to take that one first?
Yeah, the low price of the EV will more attractive for the consumer. Yeah, to switch to it, to enjoy the new technology with their club or friends together.
Does anybody else want to add anything to that, Phil?
Yeah, sure. So, there's, two costs really. One is the running cost, or the cost of maintaining, the vehicle, and the other is the initial purchase price. I think for consumer applications, people buying personal automobiles, really they're looking at the initial purchase price primarily, and not so much how much it costs to maintain the vehicle. But all the predictions are that electric vehicles are going to be a lot less costly to maintain, to maintain than internal combustion engine vehicles, because of the less mechanical parts and that are in electric vehicles. So I think as people start to see that, and it starts to penetrate the consciousness of people, that'll be an additional factor for purchase of electric vehicles. A large driver of the cost of electric vehicles is the materials cost. Of course, the battery is the main cost, and those costs have come down significantly over the last 15 years or so. There's also drivers for cost in the passive components, because especially the ones that are used in the powertrains tend to be pretty large. And at KEMET, we're always looking for ways of decreasing the cost while maintaining the performance and quality.
Yeah, definitely. And there's definitely a large scope for passive component manufacturers such as yourselves. Every increase in efficiency you can achieve can also help in decrease costs through savings at the battery level. So if your components can increase efficiency by 5%, that can for example, just picking a number out of thin air, but that can save the battery, if you can save 5% on the battery cost. So anyway, we're starting to run out of time. So before we close the session, just one last question. We've concentrated so far on surface vehicles, and just to move to something slightly different and a slightly different outlook for future mobility, I want to ask about flying cars, vertical takeoff vehicles, or drones. So at CES this year, GM talked about their plans for developing VTOLs. There's also lots of other companies out there who've invested in or are developing products on this front. I just wonder what the panelists' thoughts on this were. How do you think it's going to be a significant mode of transport in the future, and how is it going to affect electronic and component design for companies such as yourselves? Kevin, should we turn to you first on this one as well?
Yeah, for the flying car and the VOTL, I think this technology is right now already available, but the difficult to promote this due to the climate issue and the safety. So I think there's only limited people can enjoy it only.
Phil, do you have anything to add to this?
Well, so, in terms of aerospace and flying vehicles, KEMET's been involved in the aerospace industry, through our entire history. I think for those type of vehicles, there's definitely even a higher level of component reliability needed because, of the situation that you're in the air. And you cannot have a failure. It really depends on the materials that you put in there, and we have specialized testing and quality systems in place at KEMET to supply the market for these type of aerial vehicles.
And finally, Dr. Seung, do you have any final comments on this topic?
Yes, I think flying vehicles are easier to adapt autopilot option like the airplane. So moving flying vehicles with autopilot is the same as an autonomous vehicle in the sky. So flying vehicles should be equipped with more wireless connections using different wireless networks for safety. It needs high precision satellite navigation system with multi-band GNSS antennas, and 5G connections with multi-band MIMO antennas, ISM connections for backup, and maybe the dedicated frequency band for flying vehicle to flying vehicle communications, like the vehicle to vehicle communication on the land.
Thank you very much. It would, it would certainly be a big shift in transportation if a lot of people did start using flying cars, etc., and VTOL vehicles. Anyway, I think we've now run out of time. Thank you so much, everyone, and especially those of you behind the scenes who've put this whole event together. And thank you so much for having me.
All right. Yes. Thank you to you, Adam, obviously, and thank you to Dr. Phil Lessner, Kevin Chien, and Dr. Seung Hoon Baek. And as a reminder, if you have any questions, we want to hear from you. So please go to go.kemet.com/DID-contact, and we'll be sure to follow up with your question directly after the event is over. And also be sure to check out all the other great presentations today that we have for Design It Day Automotive. So once again, thank you to the panel, and thank you to you, Adam.